So before we continue on, I want to go over how we build a stack. Now the slides are going to go over how we build a stack using arrays, and then it will briefly touch linked lists. But I want to emphasize just how simple this data structure is to build. Now we're going to build it the same way we built a linked list, which meant that we're going to use our node data structure. So we are going to, our node building block, so to speak. Private, static, because it can exist without the entire stack. Class, node, e, node. All right. And now we are going to make a node e next and an e item. Okay. So those are the ingredients we need to build a stack. And now we have to have the instance variable. Now we only keep one instance variable for a stack, and that's going to be the private node top, which represents the top of the stack. That's all we keep track of, right? Rather than keeping track of the head and the tail and the size, we just keep track of the head of the stack. We don't even bother keeping track of whether there's what the size is. So now we'll write our four methods. Public boolean empty. Although I always like when we've got a boolean statement like that, a boolean method, I like to make it is empty or is this, is that. That's just a personal preference, and I'm just going to do that because I'm the instructor and I get to decide. So public, then we have the other three methods. Public e peak, which will return the top item without removing it. Return null, right? So I'm just going to quash these errors. Return false. Public e pop, return null, and now pop will return the top item but also remove it, and then public e push, and that takes an item in and puts it on. Whoop, and we'll just do it here. Takes an item in and puts it on the top of the stack, and I believe the API says that we return the item we put in for some reason. So e item, return the item that we just pushed in. I don't know why. Those are four methods. Now two of them are trivial, so we're going to implement them right away. So first is empty. Well, how can we tell if it's empty? Well, if there's nothing in there, then it's empty. Well, how do we know whether or not there's something in there? Well, if. So return, so what we'll do is we can make an if statement, and then I'll just put it down to one line. So if the top is null, return true. Otherwise we're going to return false, but we can of course just return this boolean statement and be done with it. So so if the top is equal to null, then there's nothing in there, so return true. And if there's something there, we are just going. This statement will mean false, so we return false. Similarly, peeking at the top of the stack is just going to return the top, so that returns the top item. Return, well, specifically, we're going to return top.item. All right, now to pop the item stack, that means that we're essentially just doing the same as removing from the front, and push will be removing from the front. So how do we do that? Well, we'll make an e to return. Right? And we'll return that. All right. To return dot item. To return is equal to top dot item. So we have a top item, and we're going to return it. Next, what are we going to do? We've stored the top item. Now we got to replace the old top with the thing that's underneath it. So we will do top is equal to top dot next. And I can you know what? And as far as like null pointer exceptions, I'm just not going to worry about them for this. I just want to emphasize just kind of what a simple data structure this is. We can put in a couple if statements to protect us, that we can throw some exceptions that if we'd be dealing with a null pointer exception, but otherwise I'm not going to bother right now. So we grab the item, and we simply just say top is equal to top.next. That's it. All right, now to put a new item on the stack, well, the first thing we need to do is put the item into the stack. Sorry, put the item into a node so we can put the node in the stack. New node. And we'll go ahead and make a constructor for the item down here so we can fill it, right? Public node e item is equal to this dot item is equal to item. Okay, there we go. So we put the top in, so we put the item into a node called new top. Attach the top. New top is equal to item. So new top is equal to new top dot next is equal to the top, right? So we connect the new top to the top of the list, or to the top of the stack, right? And then we make, say, the top is equal to the new top. This makes the new item we just put on top, the top of the stack, and that's it. We just return the item that we put in. I'm not sure why that was the specified, but that is it. That is all that. That was a very quick data structure to code up. That is it. So I'll go ahead and test it in a separate video.